for this. So we're what's this? Oh, I was gonna do this and I didn't do it. So I figured it out. I figured it out. Figured out how to make an inverse convergence. I thought it was x is greater than one. I was wrong. Um, uh, Pleasantly surprised I was wrong when I tried to get this thing in here and figured out it was actually negative one divided by this that worked. It actually converges at negative one divided by two. The reason I didn't know that is due to me not testing shit. I did not did the ratio test. So instead, I did not do that. Do the ratio test to figure out that. I did not do that. That's why I got x squared than one. I assumed it because this is z is greater than one. Here, I assume the same with the IOC. And later on, this IOC apparently does not affect the later IOC interval of convergence. It does probably mathematically relate somehow. You could probably make a function that relates that IOC with this IOC if you're smart, if you play around with the numbers enough. Because IOC is basically just a fractional thing. So you might be able to transcribe that by plugging it into the original ratio and then figuring it out from there. But I did it the opposite way. I got the final result and then did the ratio test, and then I got one divided by two. I got one divided by two, therefore it is one divided by two. Yeah. So, Wolfram Alpha, I was try is another way you can figure it out. I was trying to do that too. It doesn't really help me that much. Yeah, I was gonna do it, but I think it only gives you polynomials, so it's not really that useful. Uh, Let me see what it gives me. It can load forever for all I care. Anyways, so um, this exercise is gonna show that show something to you. So let's start with this one. So we know that if you take a derivative of ln of x, we get basically 1 divided by x. And that's for this one, actually. This one is over here. So we know that if you plug in 0, it will equal undefined, just negative infinity. So you have to actually move the x0 point, this point over here, to 1. Do I like it? Do I like it that I'm not showing it off that? No, I don't. Let me, let me, let me just do this real quick to make it more obvious that this is the full equation. Oh, let's not do that. Full equation, but not that. So from there, we just do it that way. This way. Is there a pen I can use? I probably could. But anyways, so you can kind of, I was spotlight maybe? No. Is there a laser color? Is there a laser? Smart pen? Does smart pen work? No. No, 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 that's not what I want. I want basically a pointer pen. Hmm, not gonna work out, is it? Oh, is this done yet? Okay, let me just, yeah, here it is. Useless, 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 because this is useful, but this is not how I would do it. This is wrong. Um, yeah, this is right, but I wouldn't do it this way. I'll tell you why. Uh, is because you're using log here and you're approximately log, so it is a bad. This is why I was bringing this up. I forgot I was going to bring this up. So over here, I don't like this. This log, no, don't like. This I like. This I don't. I don't. Uh, I'm just a student, but I don't like that. Yeah, I'm just a student. But I don't know why I don't like that. I think someone told me that it was bad. I don't remember who. Okay, so we start here, right? Uh, we have we have this as one, so we just have one over here. And then we plug in one for each of them. So we have one, you can do the derivative and all that, but I think if you're doing Taylor series, you should know how to do a derivative of ln of x and then the polynomial afterwards. But actually, that's a mean thing to say. I'll do it. Okay. So let me just do d dx of what the? This is a vanishing pen. Okay. So d dx. So this is the first derivative. This is this one. This one is already figured out by ln of x. That is just 0 when I did that. So ln of x is so 1 divided by x, which is when you plug in 0 over here, 0 that equals 1. And then you do that again, derivative of this function over here. So 1 divided by x derivative of that is basically x negative 1, which gives you negative x. And then that's minus 2, so minus 2. So that's negative 1 divided by x squared. And then you take a derivative of this again, and we are now past this, so we're now in this one. We have negative 2 divided by x divided by 3. Because it's just parable. You get the idea. You keep on doing that, you eventually get to a point where you get to fifth order, and I just stop there. You can go further, but it's a waste of time. We see this pattern over here. We see that the n keeps on increasing by 1, so that's just an n over here. And then we flip continuously the sign, so n plus 1 with this should be applied. This n plus 1 is dependent on how it's orientated, but this one is minus the minus 1 at 1, because at 0 is 0. So at 1, you see that n equal 1, we see that happen. So with that said, we can now move on. It's not going to be a big problem. I know it's illusion. Right. Okay, let me do errors here. Now we need to know the standard power series. Over here we have negative and then the 1 minus z. And then we see that the IOC over here is this. And this is where I made a mistake. I thought this IOC transferred to the end. So my original thought was, the reason I figured out it was wrong is going to test that later on. And I think the last video you showed one because of that. This is correct. This is a-okay. This is fine. But over here it changes up to x is greater than 1 half instead, which is way better. It basically means it can converge even more. Why do I keep on doing that? So let me grab my pen. This means that in this case, if I do ln of x, as soon as you start from negative 1 divided by 2, most of this is correct. And you can see that in here. You'll see that in the graph that that is true. I think you can actually pretty much see where I'm going at. So I make this form, and there's a negative over here. So transform into 1 minus 1. So you can see that we're getting into this form, and we plug it into z this. And then we get this in z. And then that changes our IOC apparently. And it does. Miraculously, when you do a ratio test, it does increase the rate. I mean, it does increase the range because you're looking at the listing. Yes. So in reality, you can see, I don't know what the use of this is. I still haven't figured out the use for this. This is completely useless in my opinion. But let me get rid of ln. This is ln. We have this part and this part. And if you remove this part, you'll see that this approximates even more. All right. This approximates up to here. And this one, if you move this part, it approximates up to there. You can choose to change where the x starts to make a piecewise function. Either way, it'll give you a right result because it's I would personally not do one half. I now just thinking about it, I shouldn't have done one half. Because it creates this effect over here where you see there's an error there. So instead, I mean, big error you can see. I would have done, I would now do instead of that, let's look at zero over here, one. So I think one would be a good point to stop at. I think. And then you see over here, it takes a while for there to be a visible error. There is a small error, but it's a very hard error because we're not doing it at this distant to point where it keeps on oscillating forever. You're gonna have to go for a long time. You might not even figure out there's an error at all. At this point, there's no point in going any further. You've figured out there's probably a very minute error here. So I'm not going to even try because my this Desmos calculator is only wanting me to see it. Now, how accurate is it to ln of x? Over here, you see that it breaks off over here, mostly due to it being going to negative infinity. Now, let's see if I can find a place where the opposite is to where over here it breaks down. And it does. It does definitely break down at 7,000. Over here, you can see it definitely broke down somewhere. But close to, I mean, that's expected with Taylor series. So see how far it can go without major breakup. Now let me increase it by 1,000. And again, we have just made it so that the error takes a long time for it to form. And if you go to infinity about this, a goes to infinity, this becomes a perfect ln of x, basically. So we're good. Yeah, we proved that this is true. Am I going to put this graph into there? No, there's no point. This one doesn't have any point. I just did it for fun. Another thing I'll say is arctan over here was fun to do. Let me go. I mean, everything here is fun, but I don't know what I'm saying anymore. But over here, this is even more fun because you're playing with a lot of the trig identities to get this over here, negative infinity. Um, Yeah, this is a fun, it's a little bit of fun one. Because there's a large number, X is a number divided by zero, basically. Um, what you may think, well, there's one divided by X and won't that play effective role? No. I mean, it's going to be negative infinity or positive infinity, and you're going to have this effect over here, plus or minus this. Now, that's basically sig over here, X. And you can see the proof over here and everything and how we get into this state. This is another question that I like because it shows you, this was actually, you're bound to create error. I think I made this, let me just save this. You can save it, I don't care. Uh, or did I delete it by accident? Well, I didn't expect it to be deleted. Uh, uh, there you go. Okay. Will it be a problem now? Let me show you this one. This one's what we had last time. You can see that it's at the point. So even if you do the discovery trade, there's always going to be a problematic situation over here. Now, I do wonder if it's possible for me to move this way with another clever approximation with a different number. Oh, I'm thinking about it. I can't think of it yet. But maybe when I'm not sleep deprived and I'm having more of a pleasant time, I'll figure it out. For now, this is the best I did. Um, there's probably a better IOC value you can find with different something else. I just can't figure it out. Probably probably something else. Um, someone that wants to spend way more time on this than they have to. Um, yeah, yeah, yeah. I'm not doing that. Hell no. Um, and then this is another fun question. This one I don't like this because you have to have ln of 5. You can't really approximate. I mean, you can approximate that with different ways and get like, I don't know, whatever it is. So you can just linear approximation to get some kind of number. That's kind of how they did it. It's numerical analysis to get that number. Anyways, we're done, right? we're mostly done here. I think I did all the questions I was trying to do. There's more questions here, but those are for me to have fun with later on. Oh, this was a fun question I made. Don't need to know about it all yet. Need to clean this up a little bit. All right, see you later.